Hello. In this video, we will see and understand the differential pair with passive load. So basically, the understanding of what will be the gain of this circuit when the load is not the active current mirror, but it is a passive current mirror. So from here you can see the circuit. Okay. Now note that the current mirror reference current is not from the M1, but it is different current source. Okay, so for this what will be the gain? Okay, so let's go to the basics. So this is our figure, and we know that gain will be calculated from short circuit transconductance and R out, both are multiplied, and the answer we will get is GM of these two devices multiplied by R naught 2. Okay, that will be the R out value, but let's see how we can derive it. Okay, so first is GM. So when you draw the short circuit transconductance circuit, this is grounded, this is open circuit, here current source open circuit, all are ground here. Okay, this is the short circuit and current through this. So what will happen? Okay, now let's see closely. So since this is open circuit, this VGS will be 0. If this VGS is 0, this VGS is 0. Okay, and current is 0, and therefore this is open circuit. Okay, so if you redraw it, you will get something like this. And now you see here, this is 0 volt, this is 0 volt. So we know from the virtual ground concept, please visit that part 2 and part 1. From there you can see here, so whatever the change in current here, okay, will be accommodated by the this branch only and this branch only, not through the resistance. So therefore this potential will be 0. So once this potential is 0, what does it mean? This means that this current, whatever the current from this M2 is GM2 minus V in by 2 minus 0. So that comes minus GM2 V in by 2. Okay, so that current is itself the short circuit transconductance, and this current is going to ground, basically not ground, basically the same current flows here. If this is this, same current flows here. Okay, so the current flows same from this ground to this ground. Now important point is the short circuit current is minus GM2 V in by 2. Okay, but remember when you will use the active current mirror load, there you can use this current from top, and from top it is like this, and it will copy here, and this current will be added, something like that. So in the active current mirror we used to use the current from this in the copy form, and we used to add this, and there we used to get the GM times of V minus GM times of V in the active current mirror, but here we are getting GM times of V by 2. Okay, so this is the short circuit current. Now let's go to the R out. Simply let's go fast. Here all ground, open circuit. Since it is open circuit, I is 0, VGS is 0, here also VGS 0, no current through this. But since there is a R, the current can flow from this node. Okay, there is R of the current source. Okay, so if you apply Vx and the current is total, the total current is current from this to this R naught. So simply the resistance is R naught 4, this, and the resistance seen from this node is R naught 2, 1 plus gm of this and multiplied by resistance seen from here, so that will be 1 by gm2 gm1. So that is why it will come 1 r04 parallel to r02. And if you now the av will be gm1 half. Why? Because it was v in by 2, gm1 or gm2 minus v in by 2, so that is why half, because v out by v in we have to calculate. So from there it is this, and r04 parallel to r02. From here if you see, this is 2 r02. So because of this 2 r02, your value is gm times of r02. So if you see closely, the gain is defined by what? Gain is defined by the gm of this device, gm1 or 2, and the resistance seen from r04 parallel r02. But we can't write directly here, because from the calculation of the resistance we got that the resistance R equivalent is R02. Okay, otherwise this is the simpler way to write the equation. Let me write it again, that simply if you don't go to the derivation part, just simply the gain will be defined by gm of 1 and 2 and the resistance seen at this point in downward, so that will be R02. So this is the gain. But in active current mirror load, the gain used to be defined by the equation something like this, that it is gm of these two, so that is gm12 multiplied by R04 parallel R02, R04 parallel R02. Okay, so this is the active current mirror equation, and this is the passive current mirror load equation. Okay, simply you can write also the R02 parallel R04, but we saw from the R out that we can write it here, but in the calculation, then in the calculation we have to include gm 1 by 2. Okay, so just simply remember that in the since we know how to derive the how to get to till this point, how we can get to this point, but just simply to write the equation, just simply write the gm of 1 and 2 multiplied by R02 is the gain, and here in the active current mode gm of 1 and 2 multiplied by R04 parallel R02. Simply don't include the resistance seeing from here and all those things, that are the derivation part, or we can say when you calculate the R equivalent, then G short circuit transconductance equivalent, then you multiply, then you will get to this, you will reach to this point. Okay, so simply the answer is this, and this is in the active current. So hope you understand.